Hello, everyone. A very good evening to you. Hope you all are hale and hearty and doing great. I am Akshat Walian, your virtual host for this session. On behalf of the entire hackCBS organizing team, I would like to extend a very warm welcome to all of you on the day one of pre-hackathon speakers session at India's largest student-run hackathon, hackCBS Edition 3.0. Utilizing the best of the technology and communication, this year at hackCBS 3.0, we will be hosting lots of live workshops and speaker sessions throughout this week virtually. To know more about detailed schedule and more details about our hackathon, you can visit our website www.hackcbs.tech. We hope to make it a memorable and insightful experience for you all. So let us begin with our much awaited session. Today's session is based on introduction to data science and machine learning using TensorFlow, which is a highly popular open source machine learning library developed by none other than the brain team of Google. This session will cover introductions and insights about how data science enthusiasts can start with machine learning through content curated, which will make it easy and interactive to understand and dive deep into the sea of machine learning. We will cover from basics to various algorithms and the real-time applications of machine learning. With that being said, let me introduce to you all the speaker of this session, Shivay Lamba. Shivay is a Google Summer of Code mentor at Jenkins and CNCF, which is Cloud Native Computing Foundation, and Google Code in mentor at TensorFlow. Shivay is also serving as product head for Metvy. We welcome you, Shivay, and looking forward to having a great interaction with you. The virtual stage is all yours. Thank you very much.
Yeah, thank you, Akshat, for a wonderful welcome. And again, a big thanks to the entire team at hackCBS. I participated last year in hackCBS 2.0, and it was a great experience. And it's great to be now being on the other side of the platform as being a speaker. So thanks for inviting me over. And I would love to interact with everyone who is watching the live session. And even after that, as in case you come into any issues with respect to today's topic that we are going to be covering, that is introduction to data science, and would love to interact with anyone having any specific doubts with regards to machine learning, TensorFlow, or data science. And I hope that this session is a memorable one and you're able to learn something out of it. So Akshat, you can share my screen as well if it's possible.
Sure.
Yeah, thank you. Okay, so I'll be very quick in sort of introducing on how we're going to be covering. So first, I'll be covering on some basics of data science, covering some basics of TensorFlow, and then looking at a sort of a mini project or some guidelines on how you can get started with a data science project and what are the various steps and processes required when creating a data science project, and how you can actually utilize the concepts of machine learning slash data science at a hackathon. So these are going to be some of the key learnings that we'll be having today. Although Akshat had given an introduction about myself, I'll be very quick in that. I'm Shivay. I was a hackCBS 2.0 overall winner last year in hackCBS 2020, and I'm a Google Summer of Code mentor and a Google Coded mentor, and currently a Major League Hacking Fellow at MLH. So that about myself. This talk again, we're going to be talking about an introduction to data science. What exactly is data science? How you can get started? An introduction to TensorFlow and machine learning, and a quick hands-on session and some questions that we can take up at the end of the session. So first of all, coming in directly to data science, before going to the technical or the technicality of data science, let's break it down into two parts. That is data and science. So data, as we know, that whatever you see around you is surrounded by data. So it could be Also, if we're talking about virtually, it could be data of your hard drive or data on your GitHub. So all of that is data. It could be data in a hospital where there are patients' files and patient data. So data, what you see is around you, whatever you see around you is being stored in some kind of a data format. It could be used in scientific usage, it could be cultural, it could be geographical, as the diagram that as that flow chart sort of shows you. Um, and data is all around you. And as we are growing towards more and more virtualization and digitalization, the amount of data that is growing is right now even higher than exponential, because on a day-to-day basis there are more than trillions and petabytes of data that is generated. So a single company or a single social media platform like Facebook generates terabytes of data in throughout a week, throughout a month. And again, a lot of that data is being processed and is being visualized and understand. We are trying to find out a lot of different insights from that data, because earlier what was happening is that all of this data that was getting generated, it was just getting wasted and getting thrown out. But as we generated more and more data, and with time, a lot of the different scientists and computer researchers, they discovered that you can actually find out a lot of different insights from this data. And when you combine various scientific tools or scientific applications onto this data, you basically combine them together to form the domain of data science. And data science today is one of the biggest growing fields, and you'll find the use of data science in almost every different field possible. And so whether it's computer science itself, or it's the military, it's education, it's the geographics, everyone has a use case for data science because everyone is generating that data. So to be able to actually get some meaningful insight from that data without actually wasting it is the most precious thing right now. And that is why data science is one of the biggest growing fields in terms of absolute numbers. So that was like a very basic introduction on a small scale. But now coming on to like what does it actually mean from a computer science perspective, is that what we're trying to do is that we're trying to extract knowledge on what does this knowledge do, or what does knowledge convey. Basically, let's say you could have a very large data set of cricket scores, and you want to find which particular cricketer or which particular batsman or bowler thrives under the league, under the knockout games like the semifinals or the finals, to basically get those players in the auction in the next version of that particular tournament. So finding out such kind of information that cannot be directly found out from very large amounts of data, and the data can be structured or unstructured. I'll be coming on to what does the structured or unstructured data really mean. But apart from this, you could also define data science as a continuation of the fields of data mining and predictive analytics. So data mining is the art of finding out something meaningful from a huge amount of data, and then predictive analytics means finding out predictions or predicting certain outputs based on this data that has been generated or has been extracted. So again, in a nutshell, we are trying to find out certain patterns, certain insights from this data that can be used from a business perspective, and can help the organization or the firm in advancing their technology or advancing their profits, in terms of, let's say, it's a business oriented organization. So that is why data science today is one of the biggest fields, and it's being so popular. So I had mentioned earlier that the data science is finding out the knowledge from large amounts of data that can be structured or unstructured. Now, coming on to the biggest difference between both of them, structured data is something that you will find in rows and columns, like if you have worked with MySQL, or if, with any other databases, or during your childhood you have worked with tabular data, all that kind of tabular data which is well structured in rows and column format. are coming under structured data. And so some of the a few advantages is that since it's very compact, it requires much less storage. So since it's highly optimized, it requires less storage. But the issue is that it only sort of covers 20% of the entire data that we see around us. So because it's a kind of difficult to maintain the structured data, that is why you also do find it in very less quantity as well in terms of the overall data that we have, and it's much more optimized as I've already said, and it's much more cost effective to work with structured data. But in terms of the unstructured data, these are the formats, like the data formats or data sets that cannot be traditionally stored in the format of rows or columns. So a good example of this would be, let's say you're having 100 different files in a particular folder, having pictures from your holiday that you spent last year, and similarly you have bunch of different other folders containing different holiday pictures. So those cannot be stored in a traditional database. So things like your emails, different official files like Word documents, Excel sheets, or images, videos, which cannot be stored in standard databases. These are sort of randomly cluttered around your data in your database. They are randomly cluttered around, and they don't have any fixed pattern. And they cover almost 80% of the entire data that we see around us. So, and as I already said, that since they are not they are cluttered around everywhere, so they require much more amount of storage, and they are much more difficult to manage and are way more unoptimized as compared to the structured data, and therefore it's really it can take a lot of time and effort to actually clean or to actually find out some kind of insights from the unstructured data. So the biggest challenge for data scientists is to actually convert this unstructured data into a more structured format, so that you can find out insights and you can get quicker feedback on your data as quickly as possible. So that is the difference between structured and unstructured data. And something that we already covered is data mining, which is finding out or extracting meaningful information from a bunch of different data that we already have. But you could consider data mining to be sort of a subset of data science, where data science is not just about finding out the meaningful insights, but also then using predictions or predictive algorithms to actually make future predictions based on the data that is being generated or based on the situation. So that should give you sort of an insight on what's the difference between data science and data mining. So data mining can be considered as a subset of data science or a subfield of data science. And some of the examples where data science is used, I've already given a few examples. It could be data on tweets, for example, finding out what are the number of tweets that are fake or are having some kind of a discriminatory post. A lot of it is used during elections to find out the sentiment of the people. It could be finding out the real-time location and traffic levels. It could be finding out the best score possible on a particular ground on for let's say soccer match, and finding out the impact that each player gives based on their previous data and previous match performance history. So you can use data science in really whichever field you want, whether it's education, health, and that is the beauty of data science. And now coming on to probably the most important aspect of data science is, if someone wants to get started, what is the general steps that one has to take to actually go through data science. So the first thing that I've already said is the raw data. So the raw data that you see will be mostly unstructured. So a lot of it actually goes into cleaning up that data. So the raw data that we can collect can be from various resources. It could be from resources like newspapers, online websites, or large databases, government sites. So this data can actually come in from various resources. There is no one fixed source from where you can actually collect this data. So the first step is to actually clean up this data and make it in a more structured format. So the cleaning up of that data not only means that you make it more structured. But let's say if your data has some missing values or missing data, those can be removed. There are some duplicate data, then those can be removed as well. And let's say there are some erroneous values. Let's say based on you have a column which has names, but you have a few numbers instead of name. So you can remove those data that might cause issues, because having things like missing values or having duplicate values basically sort of takes more time to actually then go through. So it produces much more unoptimized levels of workflows that you have. And in case we have much more clean data, then it's much more easier to process and much faster as well. So from a cost perspective as well, data cleaning is probably the most important step that one has to take place. And most of the time for the data scientists actually does go into the process of data cleaning. So this shows you sort of a cycle where we have basically receiving an incomplete file and then removing any unwanted or erroneous values, and then cleaning the data. And normally you'll find that the data that once it's cleaned, it will be much more compact. And there are a lot of different data cleaning techniques. We use certain Python libraries like pandas, numpy to actually remove some kind of duplicate data. Then you also have libraries like matplotlib to actually visualize that data. And then you can also use techniques like normalization to actually make your data even more suited for the given problem statement that you have. So that is the first step towards the cleaning up of the data. Then the next step is exploration of the data. So, okay, once you have cleaned the data, then the next step is to actually find out some of the, at least some of the basic statistics or plots, finding out certain patterns that your data might be having. So a good example of that is, let's say you are having a data of cricket scores. So you have the batsmen and their run scored and the number of balls consumed, and on a per match basis. But some of these hidden insights, like what was their average, or things like finding out in which particular matches did they score high amount of runs and their team won. So these kind of data points, which are not directly visible in your data set, but can be actually used to uh, your to a good effect in actually finding out the solution to your data science problem. These can be found out using various techniques. A lot of times we are using things like statistics, finding out averages, means, standard deviations, and using those as a means of actually calculating or proceeding ahead, because usually these will be much more important as compared to the data that we just see in front of us. So things like averages count are playing a big hand, and they play an important role. So basically, data exploration is just finding out hidden patterns that are not directly visible to us, and then using these patterns to actually propagate our model further, or to find out hidden insights that can be actually used. So it could be something like finding out the frequency distribution, or it could be finding out the standard deviation, or it could be something like finding out some kind of, and using some basic tools, again using some basic Python libraries and some statistical tools to actually find out those kind of insights. So once we are done with cleaning up the data and exploration of the data, where we are finding out some basic stats that now can actually be used to further help solve the data science problem, what we're doing is feature engineering. So what does that mean? So normally what happens is that a few of the features for any particular problem might not be the most optimized. So let's say in case I have an example, a data set of different kind of birds or animals, right? So, and I have a data where we have the serial number, we have the name or like the nickname of that particular animal, then we have the animal breed, and we have let's say the number of and those endangered species that are left on the earth, and you want to predict what is the and we have basically their numbers based on the year-wise data, and you want to predict, okay, what will be the population of this particular animal after 10 years. So in that scenario, a thing like their nickname will not be useful at all, but things like finding out the rate at which they are declining, that can be a important aspect to look at, and finding out their yearly decrease in numbers can be also calculated by using the data that we have. So feature engineering is basically just finding out those specific metrics that can best help solve a particular problem. So if I'm having a base problem of finding out the impact of global warming on the lifespan of animals, the most important aspects for me would be the yearly decline in their population in any given year, and not really the nickname of that particular animal. So it's very important while doing your feature engineering that you identify those specific metrics or those specific columns which are the most important for that particular problem. Again, for different problems, you might be having different subsets. So something like finding out what is the most commonly used pet name. In that, probably the pet name might be a good feature to have. As you can see over here, there's an example where we are detecting the number, and we are detecting handwritten drawing, and we are detecting the digit out of the handwritten drawing. So in this case, the features that we have are the curvature of the number, and using the curvature, we'll be able to find out the number, or we'll be able to detect the number. And we use certain statistical techniques like correlation. You'll be studying about this in case you're in your computer science degrees or in your degree and have mathematics. So you'll be learning about correlation. So usually you have those kind of techniques to actually find out which might be the best particular features. Again, either you can handpick or you can use statistical techniques to actually find which might be the best features. So far we have covered coming in from the raw data with our problem statement and cleaning up the data to remove any duplicate values. Then we are finding out certain patterns which will be used in the feature engineering to best suit the particular problem that we have. Then finally, we come on to the model learning. And that is where we are basically doing things like analysis on top of the data that we have. Usually the input data that we have, we use or we run machine learning models on top of that to make predictions where the model itself is extracting features or information from the data that we have provided to it, and it is able to understand the problem and then make predictions out of that. So it analyzes the features and it extracts the knowledge base about the data set that we have created or the input data. And this data is also known as training data. And once it is able to find out everything, then we come on to basically our model has now learned. So then we come on to verifying or experimenting with our model, where we now give it a new data and which it hasn't ever seen, and we make predictions on top of it. And in case the predictions are good enough, then we can continuously improve, or in case there are some improvements that might be required, we can update the model, let's say change the number of features that we have used, or do some more data cleaning and then rework on our model. So this is like a global cyclic process that you will be working with in case you're working with any kind of a data science pipeline. So that sort of comes to the data science pipeline. And now coming on to machine learning. So in a traditional programming environment, you'll be having your data and your program. So let's say we're having a basic calculation or a basic calculator application which takes in the numbers and it takes the operation. So it could be like plus or minus, subtraction or addition, and then it will get the input data, it will use the computational operation, and it will give you the result based on the operation. But this is the traditional programming that we are well versed with. But in a machine learning approach, what happens is that the machine learning model does not know which particular operation it's performing. So let's say I give a data of the input numbers of 3 and 5 and the result as 8. So the machine learning model or the approach will first look at the data. It will find out, or it will extract the features from the input data, and based on the result, it will first predict what is the operation. And once it has predicted it successfully, now you can give new data to it, and it will now predict the output based on the predicted operation that it is performing. So that is like the core difference between traditional programming and machine learning programming. And so apart from like the basic statistics and computer science, machine learning is also being used to make suggestions, doing a lot of pattern recognition, and doing a lot of different operations where we are using using the power of the computer to actually find out patterns and basically make predictions on its own. So that is where machine learning is also being used. And if you compare the machine learning pipeline to the data science pipeline, you'll find that it's actually quite similar. Because in machine learning pipeline also, you're collecting data, you're cleaning it, you're doing feature engineering, you're making a machine learning model, and then you validate it and you deploy it. But as compared to data science is usually for specifically for solving some kind of a data related problem or some kind of a business problem. But machine learning is also being used a lot for research. So that is like a slight difference between both of them. And there are a few different categories for machine learning, one being supervised learning. So in supervised learning, we basically we already know the different classes. So let's say I'm making an animal classifier, and I'm detecting or classifying between land animals, birds, and sea animals. So I'll be already being given the different classes. So what does class mean? Basically, a machine learning class is where you have a bunch of different data sets or data that have similar features are characterized as a class. So you'll be already given the data and the input classes, and you train the model and give it the class, and it will automatically first identify which particular type of data are characterized as one class. And now based on a new input that we give to it, it will send it based on the features that that particular new data has. It will classify it as one of the already existing classes. But in unsupervised learning, that is completely opposite, where we are not giving the already pre-known classes. Now based on the features that the input dataset has, and based on the closeness of the features between different input dataset, it will create the classes on its own, and the machine itself will create the classes. And once it has done that, and whatever new data that you give to it, it will predict and classifies one of those own predicted clusters or those classes that it creates. And reinforcement learning is like an extension of unsupervised learning, but it is used a lot in robotics, where the agent or like the machine learning learns from the feedback of its environment, and it's commonly used in robotics as well for the self-learning capabilities of a robot or self-traveling. And that sort of brings an end to the reinforcement learning. Now I would love to give an introduction to TensorFlow. So for those people who might not be knowing about TensorFlow, so TensorFlow is Google's open source machine learning library. So it is one of the most popular machine learning libraries to actually train deep learning based models. I didn't cover what exactly is deep learning. So machine learning has a subset, or data science or deep learning can be considered as a subset of machine learning, where you're having much more higher number of computations, and it's usually modeled after how the internal brain structure of our brain works. So it is basically similar to that, and deep learning uses TensorFlow a lot. So you find a lot of usage for TensorFlow. So now coming on to like why TensorFlow is being used. Uh, TensorFlow is specifically used for a lot of the production grade applications, where the number of computations that might be required are much higher as compared to a standard or a simple program. It has highly optimized numerical arrays, which are tensors, which are matrices of different arrays, and These are used for high degree computational numerical computations, and that is why it's very popular in concepts like deep learning. So in case like someone is interested, they can come to tensorflow.org, which and you can also like visit the github.com tensorflow slash tensorflow, which is because as I've already said that it is completely open sourced. So you can go to github.com slash tensorflow, and they should give you some kind of a basic introduction on how to get started with TensorFlow in case someone is interested in deep learning or in concepts like deep learning. This can be quite handy when it comes to using or making a project on such kind of topics. So TensorFlow is highly optimized for doing machine learning based applications. And in case anyone is interested, they can definitely try out. There are a lot of different tutorials as well. So before we continue further, I would love to take some questions that people might be having. Would love to take some kind of a feedback. Let me check. And again, like in case you are having any questions, would love to take them. Sure. So the first question by Shav is, can you take me complete roadmap for learning data science? So that's a very good question in case you want to go through and learn data science. So there are a lot of different online tutorials. First, I would recommend you to first understand that what are the basic requirements for data science. So apart from the concepts of data science that I've already talked about, you do require a certain degree of knowledge in at least one programming language. It could be Python or R. So it's good to get started with either one of those. Python is hugely popular. So you can take up something like Python, and you can also take up a few of the courses, specifically in mathematics related to statistics. And there are few things apart from statistics like probability, linear algebra. These are quite popular techniques or mathematical tools that you should definitely be aware in case you want to go ahead and work with data science. So I'll be covering a few examples on a basic project using Python, where we'll be building a machine learning classifier. So I'll be talking about that very soon. But yes, so the roadmap to become a good data science test is first learning the basics of mathematical concepts like probability, linear algebra, basic statistics like mean, uh, it could be like standard deviation. So having at least knowledge of these different topics, and then having at least knowledge of one programming language is important. And then you can take up a lot of different data science related courses, since data science also requires a good amount of knowledge of machine learning as well. So having that does help as well. So you can look out for courses like the Andrew NG course on Coursera, which is one of the most highly popular courses. Or you can also go through a lot of different YouTube tutorials by Simply Learn, and there are a bunch of different resources that I'll love to share after this call, after this workshop. I'll take up the rest of the questions after going through the demo and showing you how to actually get started with any data science project. So if please could you share my screen as well? Great. So I'll be taking, or I'll just sort of guide through a very basic example. I've already created like a work book for specifically for going through today's introduction to data science, and I'll also be giving a sort of a demo or a walkthrough with TensorFlow. So I've already created this IPython notebook. So just for those people who don't know what exactly Jupyter is. So Jupyter is sort of a notebook where you can actually write a lot of your data science or Python code. So you can actually go and install Anaconda prompt. So this is like a tool where you will find a lot of different tools or um, software suites that are related to Python or for your data science needs or machine learning. So it comes inbuilt with tools like the Python notebook, Anaconda, then Spider. So these are different like softwares that are used. The Python notebook is definitely one of the most popular ones in case you're working on any kind of a data science project, because it gives you the ability to actually run each specific cell. So since I've already said that data science itself can be sort of divided into various aspects, so starting with the cleaning of the data, then doing feature engineering, model training, and then finally predicting the outputs. So since we have a very granular approach in which we follow data science, so this allows like this kind of an interface allows you to run individual blocks, and it can run one block at a time, and that way you have control on to seeing what data is being processed after each cell has been run. So the data science project that we are looking over here is the iris dataset. The iris dataset is a very hugely popular dataset, and it is one of the most commonly used beginner projects that one will take up while they are learning about machine learning or about data science. So just to give a very brief background, the iris dataset is having basically a bunch of different images of flowers which are very close in their appearance. So it's the iris setosa, iris versicolor, and iris virginica, and all of them are in which you can actually differentiate between them is based on the number of petals and sepals. So just to give a brief example, the data that will be provided to you would be the sepal length and the sepal width, the petal length and the petal width. So basically, the sepal and the petals are the features, like the physical features of any flower, since this data set is on flower. So rather than getting the input as the images themselves, we are being given the data as the petal length, the petal width, and based on this data, we'll be making a predictor that will basically create a model that will predict which particular type of flower will it be. So the data that you will be having will be a bunch of different um, data points on the petal width, sepal width, and all of those for each of the different categories. Once you make the prediction, it will predict which one of these categories does your we have a lot of different Python packages that you can have, or Python libraries, and sklearn is an open sourced library. So I'll just quickly go through sklearn. So basically it's a very popular specifically catered towards machine learning, where you actually find a bunch of different things. You find various other other really useful libraries that you can actually use directly from sklearn, and it is really great for someone who wants to get started and directly use a bunch of different models without creating their own custom model. So what we are doing over here, the first thing that we see is the sklearn .datasets. So there is a bunch of different datasets that are pre-existing on the iris on the sklearn. So we are loading the iris dataset, and so that is like the first cell that you see. So the functions that we have over here is this function that is load iris that will actually load the the data set from the sklearn datasets into our local environment. So in case, like, let's say if I had to do something like print iris, it will basically show you, and if I run this, it will actually show you the so it's an array of different values. As I've already said, that the value that you will see is the petal, the sepal length, the sepal width, the petal length, and the petal width. So those are the numerical values of the values of these different attributes for each and every different flower. So instead of having the flower images, we are having all these different images. And as you can see, the total width, so we have like a huge number, which will be coming on to later, but we basically have almost 150 different data points available within this particular data set. So the second cell basically just loads the data set from the sklearn website locally to your environment, which you can see from the iris dataset. Now, just to give the background on the next cell, basically the iris.keys basically provides you the column headers, or what are the main points that you will see. So it has something like the data that you see over here, right over here. It will have the target. So what is now the target image or the target names. So for us, the target names are the different flowers. And then you have something called the feature names. So feature names, as I've already defined, are the 4 features that describe any image of or any flower, or to actually uniquely identify them, right? So over here, as you can see, we just did iris.feature underscore names, which gives you the features of the iris dataset. And iris.data.shape. So basically, since the data is usually in a format, in a row or a column wise format, the dot shape function is giving you things like the total number of rows and the total number of columns that you have within your data. So once we are done with that, as you can see, going forward, we are having we are just sort of, like, printing out what are the different types of iris. So we have the three different types that we have already described. And the iris dot target is basically the prediction that which particular data set is it actually belonging to. So the values 0, 1, and 2, what did you refer to is basically 0 means that it is the first type, that is the iris setosa. 1 means that it corresponds to versicolor, and 2 it means it corresponds to virginica. So these are the data already given to you. So based on the features that we have, that is the sepal length, sepal width, and the output data that we already have been given as the target, we will be finding out, or our machine learning model will actually be able to extract the features and correlate them to the predicted output, and it will now be able to identify the next data that we give to it and predict which particular value will it actually belong to. So this one gives you, like, the iris.target is all the different target values. So just to give a context, the first value that we see is 5.1, 3.5, 1.4, 0.2. The target output is 0. So that means that the first row with the values that you saw belong to iris setosa. So that should give you how they are targeting both the iris dataset and the target, right? So the feature names, as I've already said, are the 4 things that you have seen. And now coming on to the pandas. So basically, as I already said, that a lot of the data science is usually revolving around very large data sets. So traditionally, it was very difficult to handle such kind of large data sets, but Pandas is specifically a library, or software library that has been made specifically for handling data, or handling large amount of data, and what we call as the data sets. So it has its own like we have different kind of data structures like arrays, queues. So Pandas has its own specific data structure called data frames, which helps you visualize all your data in very beautifully formatted rows and columns, which will be coming on to very quickly. So as you can see, you can actually import pandas, or let's say if you're running any particular uh, data science project locally and you want to actually download a Python library, so you can actually use the command pip install. So basically, a pip is the Python package manager, like we have npm for Node.js based applications. So using pip, you can install any Python library that might not be locally on your computer. So you can do something like pip install pandas, which will install all the different all the different dependencies of pandas, and then what we're doing is that we're just importing it and giving it an alias name. So now we are coming on to what I talked about, the data frame, which is like a two-dimensional data structure that is very similar to how we have rows and columns. So where over here we define a data frame by the name of TF, and we are converting the raw data that you saw in this format into something that will be visible in this. So what we have done is that the columns that we have covered, those were given the name of the features, so that was the sepal length, etc. And the data itself is converted into all, or it is automatically mapped into the rows and columns by giving that over here. And what you see over here is like for defining, okay, what is the type or what is the data structure exactly. It will basically, we can use the type function in Python to find out what particular data structure is it. So you can like even do type for finding out whether a number is a float number or it's an integer. So now basically what we can do is, since I've already said that the data sets themselves can be manipulated. So what we have done over here is, the better DF, what we have done is basically combined two different data frames. So the one of the data frames was the one where we were displaying just the petal or the features. Now we have also combined a new column to it, that is the target column. And why we are doing this is so that once our model trains, it is automatically able to correlate the different features that we have along with the target value. And that is why we combine both of them together, and you find over here. Now, let's say if you want to visualize the data, at times by visualizing the data, you can understand the different features, or able to better understand the distribution of the data that actually goes through. And for those, you have a lot of different libraries. A few of them are matplotlib and cmon, which help you visualize the data on xy axis, or even in three-dimensional if you want, if you have much more sophisticated and much more data. So there are different ways in which you can actually visualize the entire data that you have. And that is why I'll not be going over too much into over here, but basically what we're just doing is we are creating a scatter plot. It is a kind of plot similarly to like a bar graph, or let's say a pie chart. Basically, the scatter plot takes a huge amount of data in the x and y axis, and it basically just drops them, and you can see the visual, like how the data is actually spread across. So over here, what you can see is that based on the sepal length and the petal, the sepal length and the petal width on the y and the x axis, how the distribution of the different kinds of flowers is actually there. So based on this data, it should give you an example. It should give you an insight on how the machine learning algorithm itself is actually identifying this particular information and using it to actually predict which particular data set will it actually belong to. So and as already said that you can visualize the data better with libraries like matplotlib, because again, given the time, and just sort of skipping over this part. So now we'll be looking at an algorithm, like an actual machine learning algorithm. So this is something that I didn't cover, but we have a bunch of different machine learning algorithms, and as I already said that we had the two major machine learning types. One was supervised learning, the other was unsupervised learning. So in supervised learning, you have a bunch of different algorithms like KNN, which is the K nearest neighbors. So just to give a very sort of simple example of the KNN algorithm through a picture, I'll not be going to the mathematics or how it works internally. So basically, based on your classes that you have. So since it's supervised, the classes or the clusters are already known. So let's say I have a cluster of the blue objects. So these might represent cats. The red ones might represent dogs. So basically what we do is that, let's say you are having a graphical plot. I'll quickly just draw it out. And so let's say we have a graphical plot and we have a bunch of different data that represents cats, represented by C, and you have different, these are like different data points that are represented by D for docs. So let's say now a machine learning algorithm, it basically wants to predict whether the next input that we'll be having will be a cat or a dog. So it will, let's say it basically plots a few points, a few testing data over here. Now what the KNN algorithm does, it basically calculates the distance of these data points from each cluster. So we basically make like lines, or based on since I've already said that it's KNN, which is like K nearest neighbors. So K is usually like a variable. You could have K as 1, 3, 5, and it's an odd number, so that the prediction that you make is belonging to one of the classes. So basically what happens is that you make those like based on the value of K, we find out that how many of these predicted values actually lie in one of the other class. So whichever class will have more number of the predicted values, that will be the class that will be actually winning the prediction. So what does that mean is that, let's say in case we had 20 different data points, and we had like, let's say 13 of those, we had like 19 different points, and 13 of those lied in the D, or they were closest to D. So that means the higher number of the data points that are closer to a particular cluster, that will be the class that to which the new data will actually belong to. So that is like a very high level example of how the KNN algorithm works. So what we are doing is, based on this data, we import the KNN algorithm again from sklearn. So as I already said, that apart from the datasets, it also does have a few different machine learning algorithms that are embedded in itself. In case you had to write like an algorithm, KNN algorithm by yourself, even that is something that is possible. But we, just for the sake of the demo, we are utilizing this. So like just to sort of give a very heads up, what we did earlier was where we combined the two different kind of data. We were basically doing a lot of data cleaning, and then by, let's say, by actually visualizing the data, we did the process of the data analysis, or finding out which particular features, or finding like creating these plots to actually visualize the data. And then we found, okay, which particular data points will be the most important, which were part of the feature engineering. And now using the KNN, we are basically doing our model training. So as you can see, like what we are planning to do is that, as I already said, that sklearn already has some pre-built models. So we are importing the KNN model, and what we do is that we get the data. The X represents the data of the 4 different features, and Y is basically the target. So based on any given data, you will be having a separate target, and then we basically use the function .fit, which basically is nothing but it is training, or it is basically adapting the, like the algorithm itself is adapting itself to the data that we have. And once that is done, you can it has basically trained itself on top of that data. So now over here, as you can see the test flower, we are basically now giving it an output, or like a test data, and we are using the predict function to actually go through this test data and predict which particular data, or which particular type of flower will this particular value be. So you can give like any kind of a test data set to it, and you can find out the prediction. And over here, as you can see, like we are using .fit, and then we are finding out the score. So when you see the score, you'll find that it's 97%. And before that, if you look over here, the prediction that we got was a 0. So that means it belonged to the 0th value. And basically, the score or the value that you see 97% means that 97% of the times the model was able to correctly predict which particular data, like whatever data it had based on the type of flower, it was able to correctly predict the type of flower using the data. So it had like a precision or an accuracy of 97%. So that should give you an example. And let's say if my accuracy was lower, I could have trained the data much more. So what you see over here is basically within the model training, it has a lot of different input parameters whenever you are having any kind of a data or a machine learning. So as you see over here, like let's say if your prediction was really bad, or let's say if I increase the number of neighbors. So right now the number of neighbors, since it's KNN algorithm, if I change the number of neighbors, it should actually change so in this case it doesn't, but basically let's say if you have a lot of error coming in your data, so you can actually make changes to your data set itself and to your input model that you're using, and that way you can find differences in the data, because the way it actually extracts the features will be slightly different. So this way you can use different kind of machine learning models, and this is just like one simple example of the KNN machine learning algorithm. So this should give you a sort of an insight on like how to get started. And as I've already said that we started with the loading of the data, so that is the raw data. Then used pandas to actually clean it up and make it more presentable, and combined it with the targeted value. So this was part of the data cleaning. Then we visualized the data using matplotlib and using pandas, and then we found out certain features, like which particular features were the most important for feature extraction. And then we did the model training using the KNN algorithm, where we first fit our input data into the model, and then we made predictions out of that. So this sort of should give you a very basic example of how a data science pipeline actually works. And now I would love to take up the questions. Okay, so the next question are the prerequisites for data science. Also, in case once the questions are taken up, I would love to connect with everyone. So you can connect with me on these social handles. So you can connect with me on Twitter, GitHub, and LinkedIn in case you want to have any other questions. And I'll be also in the Discord channel and will be part of the mentoring group. So in case you have any questions related to uh, machine learning or data science, you can connect with me as well, right? So uh, I would love to now take up the questions. So Dilip asks, what are the prerequisites for data science? So as I've already said, that the most important prerequisites are having a good grasp on the mathematics part and the actual programming language. So having at least one good programming language experience and having knowledge of some parts of machine learning are also important, because we do use these machine learning models as part of the data science process. So having those are very important. And the next question by Anushka is, what are the skills needed to learn data science and machine learning? I'm in high school. Oh, that's great. In case you are. So again, whether it's machine learning or data science, the most important things to consider are, uh, if you're going to machine learning, you should have a good grasp on the core concepts of programming. So not really go too deep into something like data structures or algorithms, like let's say working of the trees or the graphs, but you still need some kind of a prior programming experience with, let's say, things like Python or any other programming language, and the concepts of mathematics that I've already covered. And you can look out for the courses like the Andrew NG course on Coursera, that is quite good. And in case you want to go ahead with a more application focused based machine learning approach, because machine learning is highly used in data science and in research and also in applications. So you can have a look at a few machine learning courses on Udemy and Udacity for in case you want to go ahead with the application approach based model. So that should give you answer. And then which is better, sklearn or GraphGL? So sklearn, as I've already said, is really great for beginners, for those people who are just getting started and want to quickly make a machine learning model, or want to just use the machine learning model capabilities directly. They don't want to create their own machine learning model because it does take time to actually create your own. But the issue is that with sklearn, the amount of flexibility that you get the from actually for training your customized model, so that ability is sort of limited in case as compared to a standard like machine learning model that if you are creating by yourself. So that is the major difference when it comes to using sklearn. But it's really quick for beginners. It's really good for beginners and for creating really fast models that you can directly just deploy and use in your application. The next question is, what are the skills needed to learn? I think that question is already repeated. Okay, the next question is by Manan. Again, a really okay. So the next question is by Akshay, who says how to apply for the Google ML Facilitator program. So that's a good question. Although I'm not personally a Google ML facilitator, but basically on the Google website, or if you go to the Google ML Facilitator website, they are regularly releasing out the applications for becoming a Google ML facilitator every year. So it usually happens in the early part of every year. So in case you want to apply for the year 2021, you can always just continuously look, or even if I'm not mistaken, there must be like a subscriber list with on machine learning, if I'm not mistaken, for the ML facilitator program. And you can always like connect with the ML facilitator themselves, who have been past facilitators on LinkedIn, so that even they are able to tell you. But usually you just have to look out for the forms that usually appear during the early part of the year, right? So that should give an example. And just in case, like at least from my personal experience of having applied for it, the only thing that they really look at is that whether you are having at least some basic knowledge of machine learning, and whether you are having the willingness to actually teach people, because as a facilitator you are required to teach the students about the concepts of machine learning and making machine learning more accessible for the students who are just starting out with programming or machine learning. So that should answer the question. And then the next question is by Manan, who asks TensorFlow versus PyTorch. So that's a really interesting question, Manan. So just to give a very basic overview, both TensorFlow and PyTorch are highly popular open sourced libraries that have been specifically made for high computational mathematics, or high computational uh, processes that go on under any kind of a machine learning application or a machine learning project that one is going through. So TensorFlow is an open source library that is built by Google, and PyTorch is maintained by Facebook. So both of them are having their own pros, and a few of the applications which you will find are much more optimized with PyTorch, and a few of them will be more optimized using TensorFlow. So based on your, but again, like the gap between them has sort of, been closed a lot. Uh, in case you want to specifically look at which one has a better view, or which one is actually better for a particular use case, you can simply just, go through a few Stack Overflow links on seeing for your particular like machine learning application that you are working on, which one might suit you better, because both of them are highly popular. Both of them are the most commonly used popular libraries when it comes to deep learning. So with like based on your particular framework, you can sort of go through and try to use either of them and see which one gives you better results. Because for a few of the applications, like for, let's say, for text summarization, for object detection, for things like image segmentation. TensorFlow does have a better hold, but again, like it really will depend on the application that you have. The next question is by Rishabh, who says, where to host our model for integrating. Okay, so that's a really good question, Rishabh. So again, you can actually now leverage the use of TensorFlow. So in case, if you allow, I would love to share my screen and show. So we had earlier gone over the TensorFlow um, website. So TensorFlow, as I already said, is a hugely popular machine learning open source library for deep learning, but it also does have a lot of support for not just your Python based machine learning applications. So as you can see over here, you have something known as TensorFlow.js, about which Jason Mays from Google will be actually taking up a session on 7th of November for hackCBS, because it has a special price. So this was made specifically for a lot of the web developers who didn't want to take up Python. These were like hardcore JavaScript developers. So TensorFlow.js is a JavaScript library which can utilize machine learning models. And then, like Rishabh, your question is a very good question. In case you want to load them for your Android or your iOS specific applications. So we have something called TF Lite, which is TensorFlow Lite, which are sort of cut down models, because like the TensorFlow models can actually be quite resource heavy. So a lot of times you require things like a GPU or a graphics process unit to actually run them smoothly. So you'll usually find, like, really cut down versions of these high-end machine learning models, and to actually use them directly to your mobile. So TensorFlow Lite has a very good compatibility with Flutter, with Dart, with Kotlin. So in case you want to load a machine learning model specifically onto, let's say, an IoT-enabled device or a cross-platform web application, or a like a mobile application, you can use a TF Lite. So that should give you an example. That should give you an answer. And this is like TF Lite is specifically for like, let's say in case you are going with creating your own model, but you can also look at cloud platforms like GCP or AWS, because these will actually give you a lot of different tools where you can actually just use, like, you can build your machine learning model on these tools. And so you have like the Google Cloud, you have AWS SageMaker. So these are like cloud platforms where you can actually deploy your machine learning models directly. So they are getting stored on the cloud, and then you can directly then utilize by creating endpoints which will fetch which will basically send your data to these machine learning models. They will fetch the results and you can find them. So like this is an alternative technique that you can use for integrating, like you can host your models on these platforms. Then the next part, the next question is by Manan. What future does MLOps hold, since integrating Docker and Kubernetes helps in productionizing and monitoring our model? So that's a really good question, Manan. And MLOps is one of the most growing fields. So if since you have already talked about Kubernetes and Docker, a very popular tool is called Kubeflow. So these are basically these are automating your machine learning models, or containerized models. So again, like to just give some kind of an background to those people who might not be knowing about Docker and Kubernetes. So in the modern cloud architecture, we're not having these servers running where locally you are having all of the different data and the data processing is doing. So today we are moving to a serverless architecture where you don't have these dedicated servers, but all of your major components, or like those data are actually or your software infrastructure is now there on the cloud, and those are part of these containerized applications and these containers which are on the cloud and can be accessed virtually by any laptop anywhere, and you're not dependent on that local server. So these containerized applications are created, are like basically these softwares are done using Docker and Kubernetes. So similarly, the standard machine learning operations that used to run locally on your laptop can now be run on the cloud in this kind of a containerized environment, and that is what we call as ML ops. So this comes like sort of comes from the DevOps, which is like a very popular terminology being used. So when you are having your machine learning workflows being automated and put on the cloud architecture, ML ops is a really hot growing field right now. And things like Kubeflow, and you can actually look at a few applications of ML ops in CNCF, that is the Cloud Native Computing Foundation, because that actually supports Kubeflow program. But Kubeflow is like just one example, which is using a Kubernetes on the backend, but you will also find a lot of other different MLOps operations. So one of the Jenkins project for which I was the Google Son of Code mentor, that where we created a Jenkins plugin for machine learning, and that we were basically combining DevOps with the Python notebook to actually automate and sort of create like a DevOps environment for IPython notebooks. So again, like MLOps, as Manan you said, is a growing field, and it's definitely something to pursue if you're interested in serverless architectures. And yes, as hackCBS officially says, do tune in for the TensorFlow.js because that is going to be one of the most, like most amazing sessions that you will see, because I've given a session myself alongside Jason, and it's going to be lovely. And for those people who are core web developers, should have now understood some basic concepts of machine learning, and you should be definitely able to use TF there. So again, like I'll not be talking a lot about it. I'll let Jason handle that on 7th. So again, thanks a lot for the wonderful questions. And again, in case you want to connect with me, you can follow me on Twitter at @howdevelop, on LinkedIn. You can connect with me on LinkedIn with Shivay Lamba. So again, a very big thanks to Akshat and the entire team for inviting me over and letting me part of this wonderful session. Akshat, you're muted. I'm sorry.
Okay. Thank you very much, Shivai. It was indeed a very informative session. Hope our audience get to learn something new and innovative today. Shiva is available in the mentors channel of our hackCBS server. You can ask him questions and queries there as well. Thank you very much, Shiva, for enlightening us with your knowledge. It was amazing to host you today. Thanks to
Absolutely.
our patient audience as well. We request you to fill the feedback form and get the certificates of this session. Link to the feedback form is already dropped in the description. We are having our next workshop tomorrow at 10 a.m. on product development by Gurtej Singh. So set up your alarms right now because it's gonna be one more amazing session. Hope to see you all there too. Thank you very much for joining us and have a good night. Thank you
Thank you.
everyone. Bye bye. Take care.